Now today I'm going to talk about capillary fluid exchange mechanism. Yes, what the topic is? Yes, please. Capillary fluid exchange mechanism. At the very beginning of this mechanism, we have to go through some pressure, and everyone we all know that in it is a capillary, and there is two in obviously arterial in and venous in. Obviously, what's the two in arterial in and venous in? And at the very beginning of this discussion, we have to throw some pressure, colloid pressure, interstitial fluid pressure, which is negative, interstitial fluid colloidal osmotic pressure, okay, then plasma colloidal osmotic pressure. Now, what is the pressure is? When blood is gone through this capillary as well as plasma, the plasma is trying to move outward from the capillary into the interstitial space due to the force of gravity. So this force by which the plasma is trying to move outward is called capillary pressure as well as hydrostatic pressure. Okay. So what is the reason of this capillary pressure or hydrostatic pressure? Is due to gravity. What is this? Is due to the force of gravity. Okay. So and the capillary pressure, yes, please, the capillary pressure have a value. It's both the arterial end and venous end. If the divide is arterial end and venous end, the capillary pressure is different in arterial end and venous end. And in the arterial end, the capillary pressure is 30 millimeter of mercury. Yes, please, 30 millimeter of mercury. And in the venous end, the capillary pressure is 10 millimeter of mercury. Okay. And there is a pressure which is called interstitial fluid pressure, and that is negative. What is that? What is interstitial fluid pressure? Beneath the capillary, it is, what is this? Interstitial space containing interstitial fluid. Okay. Uh, Let me talk about this. And in this, suppose it is interstitial space containing interstitial fluid. Okay. When when the interstitial fluid is trying to move away from the interstitial space, okay, yes please, when the interstitial fluid is trying to move away from the interstitial space, the pressure is called positive interstitial fluid pressure. Okay. So when the interstitial fluid is trying to move away from the interstitial space, the pressure is called positive interstitial fluid pressure. And conversely, when the fluid is trying to move inward the interstitial space, the pressure is called negative interstitial fluid pressure. Okay. And now in this segment, the fluid is trying to move outward. That means the fluid is trying to move outward, and where is in trying to move in interstitial fluid. Okay, so the fluid is trying to move in interstitial fluid or interstitial space. So we can say that here the interstitial fluid pressure is obviously negative. So the interstitial pressure int and arterial int and in balancing is obviously 3 millimeter mercury and balancing is 3 millimeter mercury. Okay, here is the another point: plasma colloidal osmotic pressure. As we know, the blood contain plasma protein. Obviously, the properties of protein is what is colloid, and the properties of colloid is osmotic pressure. Yes, please. What is this? So the plasma colloidal osmotic pressure is the pressure that exerts by plasma protein. Obviously, and the plasma colloidal osmotic pressure is trying to move inward the fluid. Okay, what is this? Trying to move inward the fluid, and the value is 28 millimeter mercury and 28 millimeter of mercury. Okay, and the other colloidal osmotic pressure, what is this? Interstitial fluid osmotic pressure. Why? What is this problem? Because in interstitial fluid also here is some protein and the amount is less, so the interstitial fluid protein also try to exert the pressure, colloidal pressure, which is trying to move the fluid outward, obviously. Heard, so if, what is this? Interstitial fluid colloidal osmotic pressure, colloidal osmotic pressure, and the value is obviously 8 millimeter of mercury and 8 millimeter of mercury. And the what is the point, exact point here? The capillary pressure is trying to the fluid outward, obviously. The capillary pressure is trying to the fluid outward. Okay, yes please. I am trying to, this pressure is, yes, what is this? The capillary pressure is trying to the fluid outward, outward. Okay, and the interstitial fluid pressure obviously trying to the fluid outward, and the interstitial fluid colloidal osmotic pressure also trying to the fluid outward. But the one pressure which is trying to the move fluid inward is plasma colloidal osmotic pressure. And now I will very deeply discuss that. Here is outward, here is outward, and here is outward. So the sum of outward pressure in arterial end. So the summation of outward pressure in arterial end is, what is that? Outward pressure is 30.38. That means 41 millimeter of mercury. Okay, and the pressure in venous end is obviously 10.38, 21 millimeter of mercury. Okay, and the only inward pressure, which is means plasma colloidal osmotic pressure, is 28 in both sides. So you can call this inward pressure and inward pressure. Inward pressure is 28 millimeter of mercury. Inward pressure is 28 millimeter of mercury. Yes, please. And now at the arterial end, we see that the outer. Okay, I have to draw is the nice limb. Yes. In this arterial end, outer force 41 and inward force, what is this? 28. Okay. And in this venous end, the outer force was, yes, 21 and inner force was 28. And now you can see that in the arterial end, the outward force is greater than inward force. Okay, so summation of it is obviously outward, because the outward force is greater than inward, and is called, what's this, the value is 30 millimeter of mercury, millimeter of mercury, millimeter of mercury. So this outward force in the artery ends, this outward force, net outward force in the artery is trying to the move the fluid outwards, obviously. So in the arterial end, the fluid is moved outward. Why? Because the net outward force or it is also known as net filtration force. The fluid is filtrating out, so the net filtration force is 30 millimeter of mercury. And in the arterial end, the fluid is moved outward. And what is happening in the venous end? The outward force is 21 and the inward force is 28. Okay, now the inward force is greater than outward force. The summation is obviously inward. Yes, please. 7 millimeter of mercury. And now what is happening? As well as the inward force is greater than outward force, the fluid is moved inward in venous ends, and we can call it is reabsorption. Why reabsorption? Because in the arterial end the fluid is filtrated out, and in the venous end the fluid is absorbed in the capillary again, and this is called reabsorption. So under the inward force in this venous end, also known as net absorption net absorption pressure or force, is 7 millimeter of mercury. So in this mechanism we see that in the arterial end the fluid is moved outward, and this fluid that is moved outwards is somewhere gone through in some organs, and also some fluids drains through lymphatics in the blood, and in this fluid eventually absorbed in venous and the capillary. And this is the mechanism of capillary fluid exchange. Okay, hopefully you understand, get the understand better understand of this mechanism. Thank you all.